Hello, welcome you all. In this video session, we will solve some of the numerical problems on transmibility. Okay, let us consider the first problem. A single cylinder vertical diesel engine has a total mass of 100 kg. Total mass of the engine it is 100 kg is mounted on a steel chassis frame. The static deflection owing to the weight of the chassis is 3 millimeters. The static deflection is given here of the chassis when it is loaded. The reciprocating masses of the engine amounts to be 10 kg. Okay, total mass of the engine it is 100 kg, but the reciprocating part it is 10 kg, and the stroke of the engine is 80 mm. A dashpot with the damping coefficient 2 Newton second per meter is used to dampen the vibration. Okay, determine the amplitude of vibration if the shaft rotates at 1000 rpm, and speed of the driving shaft when the resonance occurs. Okay, you need to find amplitude of the vibration and speed of the driving shaft when the resonance occurs. Okay, total mass is given here 100 kg. Static deflection it is 3 mm. Mass of the moving part, that is reciprocating part, 10 kg. Length of the stroke, that is 80 mm. If length of the stroke is given, then you can calculate eccentricity by using L by 2 for the reciprocating part, or if the length of the piston reciprocation is given, then that length divided by 2 it gives you eccentricity. And C value it is 2 Newton second per millimeters. Okay, convert it to 2 Newton second per meters, so 2000 Newton second per meter. Okay, it is the conversion. Okay, we know that to find the amplitude of vibration, this is the formula. It is derived in the last video session, where x is the amplitude of the vibration for the reciprocating or the rotating parts or machines. Okay, what is this equation? Small m by capital M, where small m it is the mass of the rotating part or the reciprocating part, m is the total mass of the machine, E is the eccentricity, omega is the frequency of the system or the natural frequency of the system, omega n is the natural frequency of the system, and zeta. So to find the amplitude you need small m, capital M, eccentricity, omega, omega n, and zeta value. Okay, for the above datas, okay, let us see what are the given datas are given. Small m it is 10 kg, mass of the reciprocating part. Total mass it is 100 kg given. Eccentricity, length of the stroke it is given. So by the length we can calculate this eccentricity by divided by 2. It gives length of the stroke. Okay, take in meters. Omega, see here, amplitude of vibration if the shaft rotates in 1000 rpm. So omega value or speed is given. By this speed we can calculate omega value. Okay, omega equal to 2 pi n by 60, where n is this 1000 rpm. So omega can be calculated by using the speed. And omega n, we already know that omega n equal to square root of k by m, where k is the spring stiffness and m is the total mass. We have total mass, but we don't have the information of spring stiffness. So let us find other methods to find the natural frequency, that is omega n. We know that when the machine is loaded, okay, we have the information, there is a static deflection of 3 mm. Okay, when it is loaded the static deflection is 3 mm. So mg is equal to k delta st. Okay, when there is no vibration, when it is only loaded with this static force, then the forces develops are mg and k delta st, and these are equal. So where m is total mass, g is gravitational constant 9.81, k is spring stiffness, and delta st is static deflection. Okay, by this relation we can find that k by m it is also equal to g by delta st. So omega equal to square root of k by m. You just replace this k by m with g by delta st, where delta st it is the static deflection and g is 9.81. Okay, substituting g value and static deflection, that is 3 mm. Here it is mentioned in meters. Okay, so we now have omega n, that is 57.2 radian per second. Okay, now small m, it is 10 kg, capital M, total mass of the engine or the machine, it is 100 kg, eccentricity is L by 2, omega value can be calculated by 2 pi n by 60, where n is 1000 rpm. Okay, substituting using that equation, you can find omega n equal to square root of g by delta st. Okay, so now we have all the values except this zeta. What is zeta? Zeta is equal to damping ratio, zeta equal to c by cc, where c value it is given here 2000 Newton second per meter, and cc value is 2m omega n. Mass is given, you consider total mass, not only the mass of reciprocating part, and omega n equal to square root of g by delta st. So now you have all the datas. Okay, so just substitute all the values and find what is the amplitude. Similarly, speed of the shaft at resonance. Okay, speed of the shaft at resonance. To find this speed, we already know the natural frequency or the frequency. At resonance, omega equal to omega n. You substitute the value of omega n. Again, with this relationship, we can find the speed. Omega equal to 2 pi n by 60. You find what is this n value. Okay, that is the speed at the resonance. At the resonance, you put what is the natural frequency value. Okay, putting natural frequency value, we have the speed is 546. Okay, this is the speed of the shaft at resonance. Okay, this is the first problem. Okay, let us solve the second problem. A machine of total mass 17 kg, mass, total mass capital M, is mounted on a spring having stiffness. Stiffness is given. Within the machine has a mass of the machine has a mass of 2 kg, has a reciprocating machine with a stroke of 7.5 centimeter, and speed is 6000 rpm. Assuming the motion to be simple harmonic motion, determine the amplitude of the machine, transmibility, and force transmitted to the foundation. Okay, this is a machine where total mass capital M, it is 17 kg, and small m, it is 2 kg, and speed is given 6000. By this 6000, we can find the natural frequency of the system, omega equal to 2 pi n by 60. Okay, L value, stroke length is given, so we can find the eccentricity, L by E equal to L by 2. Okay, again it is asked to find the amplitude of the machine. You just substitute all the values. Small m, it is 2 kg, capital M 17 kg, eccentricity is L by 2, omega value you can find it by 2 pi n by 60. Okay, omega n square root of k by m, k value it is given, ml is 17 kg. So substitute zeta value. How to find zeta value? Okay, zeta value, it is a given value here, it is 0.2. Okay, take zeta equal to 0.2. Okay, by substituting all the values, you will get the amplitude. Next, second, transmibility. We already derived the transmibility equation. Zeta equal to 0.2, omega it is calculated by 2 pi n by 60, where n is 6000 rpm. 2 pi n by 60, you find omega n equal to square root of k by m. Zeta value, it is 0.2 given. Substituting all the values, use this equation, find the transmibility. Similarly, force transmitted to the foundation. Okay, we know the relationship between transmibility and this force transmitted. So epsilon equal to transmibility, it is calculated here, it is 0.27. Epsilon equal to ft by f naught. F naught can be calculated by m omega square epsilon, where m is mass of the reciprocating. It is not the total mass, it is mass of the reciprocating. E is eccentricity, omega value is the frequency. You substitute this and find the f naught, and epsilon it is the transmibility, it is 0.27, it is calculated here. Okay, by this you will get a force transmitted to the foundation. So ft value, it is 7900 something newtons. Okay, thank you.